Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the oblique lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now an oblique line is the one which happens to be inclined to both the reference planes, that is horizontal plane and the vertical plane. And due to the inclination of the oblique line with the two reference planes, so neither of the front view or the top view, they will be drawn parallel to the XY reference line, and we will be able to obtain the apparent length projections of the line onto the horizontal plane and the vertical plane. And neither of the front view and the top view, they will provide the true length projections of the line. So in case we are required to evaluate true length of the line alongside the true inclinations of the line with the reference planes, then we are required to use the principles of rotation of the line method to evaluate the true length as well as the true inclinations with the reference plane. Now here we have been provided with a real life situation into which we have got a tower which is going to have the length equal to 15 meters. So this is a tower which is available with us. We have got an observer who is lying at the top, who is sitting at the top of the tower, and this observer who is located at the top of this tower, he is viewing these two objects, object A and object B, from the tower. So the angle of depression that we have got corresponding to the observer viewing the object number 1, this is equal to 30 degree, whereas the angle of depression corresponding to the observer viewing the object number 2, it is equal to 45 degree. And another information we have got that the object B, it is located in the westward direction, that is object B is due west direction, whereas the object A, it is available at northwest orientation. So this is the northwest orientation. So northwest orientation will be at an angle of 45 degree from here. So this is north direction, this is south, this is west, and then here you have the east. So the object A, it is located in the northwest direction, that is between north and west, at an angle of 45 degree. So using this physical real life environment, first of all, we have to convert this situation into the orthographic projections, and once we obtain the orthographic projections, that is front view corresponding to this string OA and the string OB, that is O dash A dash and O dash B dash, and similarly we will be obtaining the orthographic projections corresponding to the strings OA and OB in the top view. So once we are able to obtain the front view as well as the top view projections corresponding to these two strings, so these two strings mean that here the rays of sight from the observer, as the observer is going to view object A and as the observer is going to view the object B. So we are required to evaluate the true length of these two strings over here. Besides this, we are also required to work out the distance of the object from the observer as well as from the tower, that is O dash A dash true length and O dash B dash, that is OA true length and OB string true length needs to be observed. Besides this, the distance between the tower bottom and the object A and object B, it also needs to be evaluated. So let us see how we can go about converting this real life situation into the orthographic projections, that is front view and the top view projections of the oblique line. And thereafter we will be making use of the fundamentals of the rotation of the line in order to obtain the true length of these two distances over there, that is OA true length and OB true length we are going to evaluate. And we are going to use a scale of 1:100, that is 1/100, in order to evaluate the orthographic projections. So 1 meter distance will be represented as 10 millimeter, right? So here we have got the XY reference line. So we know that this height of the tower over here, it happens to be 15 millimeters. It happens to be 15 meter. So corresponding to this height of the tower equal to 15 meter, using a scale of 1:100, we have to draw a projector line which is going to decide this particular height of the tower. So this distance from the ground should be equal to 150 millimeter, corresponding to 15 meters height of the tower. Now let us say we have represented this tower over here like this. So this is our tower, right? So this tower height, it is equal to 15 meters or 150 millimeter. So at the top of the tower, we can see over here, the observer is situated. So observer, since it is located at the top of the tower, so the front view projection O dash will be obtained on the top of the tower over here. So point O dash has been located, and we also know that the angle of depression while the observer is going to view object number A, so this apparent length, it is at an angle of 30 degree from the top. So this is the angle of depression. So angle of depression means now from the top we have to use this angle is equal to 30 degree in order to locate the point A dash onto the ground. Why we have located point A dash on the ground? Because points A or the objects A and B, they are lying onto the ground. A person observes two objects A and B which are lying onto the ground, right? So the observer is situated at the top of the tower. Now with angle of depression 30 degree, the observer is able to view the object which is named as object A. So the front view projection will be A dash corresponding to this object which is labeled as object A. Similarly, the angle of depression corresponding to the observer who is going to view object number second, which is object number B, this is equal to 45 degree. So we have marked this angle of depression over here, and we have been able to obtain this particular O dash B dash length, which is an apparent length corresponding to the ray of sight or a string which is going to join the observer location with the location of the object. So these are the two apparent length projections which we have drawn using black color line in the front view. So having drawn the projectors in the front view, now we are going to proceed with the construction of these projections in the top view. So we know two things over here. First thing is that the object B, it is located in the west direction, right? So here we have taken direction north, south, east and west. So object B, it is located in the west direction, whereas object A, it is located in the northwest direction. So northwest direction means at an angle of 45 degree over here. And another thing we know that from the basic fundamentals of projections of point, so wherever the location of point A dash, that is point A in the elevation is located, so onto the vertical projector line, we will be able to obtain the projection corresponding to the point A, that is the top view projection will be obtained just below the projection corresponding to the point A dash in the elevation. Similarly, wherever we have been able to obtain point B dash in the elevation, point B, that is the top view corresponding to the point B, it will be lying just below this particular point B dash over here in the top view. So the coordinate location or the locus line of the point A in the plan has been obtained. Coordinate location corresponding to the locus line where our point B will be located has also been identified. So now we know two things over here. Once we are going to look at this tower from the top. So this observer O or point O over here will be located at the bottom over here. So this will be located onto the ground right at the bottom. So here wherever the intersection of north, south, east-west is taking. So this is the point of location of the observer as it is viewed by an observer who is going to look from the top. So when we look at this observer from the top, this point O will be located over here at the base. So this is the location of the point O. So now we need to evaluate two projections in the plan, OB and OA. So we know that point A or the object A is located, or it is due northwest direction of the observer. So if the observer is located over here, so this is north direction, this is west. So northwest means 45 degree. So in the northwest direction, so over here this is north, over here this is west. So in the northwest direction, I need to draw a projector line starting from point O and extend it till it meets the vertical projector line which is coming from the point A in the downward direction. So wherever this vertical projector line and this inclined projector line which is going to describe the northwest orientation of the observer A. So wherever this vertical line and this northwest projector, wherever these two intersect, we are going to obtain the location of the observer in the plan. That is, this is going to be point A. And similarly, having identified point A, let us now proceed with identification of the point B corresponding to the object number 2 or object number B. So object B, it is due west over there. So this is the west direction. That is, object B will be located alongside the west direction. So this is the west direction. So in the west direction, we are going to proceed with this projection from point O till this projection. It intersects with the vertical projector which is emerging from the point B dash. So wherever this vertical projector from point B dash and the horizontal projector due west which is emerging from point O. So wherever these two intersect, we will be able to obtain point B. So this is the location of OB projection in the top view. This is the location or orientation of OA projection string or ray of sight from the observer to the object in the top view. And also we can join A and B over here. So this way we have been successful in obtaining the orthographic projections corresponding to this real life environment situation. So having been able to convert this real life situation into the orthographic projections, now our job is to evaluate the true length of the distances OA as well as OB over there. So we will be able to evaluate the OA and OB true distances which are going to join the observer with point A and point B respectively. So in order to obtain these true lengths, we have to use the fundamentals of the rotation of the line. And we know that whenever the apparent length of a line happens to be parallel to the vertical plane, so the projectors drawn through these 2 points onto the vertical plane, they will be providing us with the true length of this particular line in the front view, right? So here we can see that we have got first projector line in the plan. So this is corresponding to object A over here. This is OA. But this plan projection line OA, it happens to be inclined to the vertical plane. So what we have to do? We have to rotate this OA plan projection line in such a way that it becomes parallel to the vertical plane. So in order to rotate this and make it parallel to the vertical plane, so we'll take O as our needle point. Open compass is equal to the distance OA. So this is O, this is point A. And once we rotate it in such a way that we move into this direction, and this arc has to be extended up to the locus line which is emerging from point O. So this is the horizontal locus line which is emerging from point O. So we are drawing an arc equal to the radius OA from the point O over here, such that this arc should intersect with this horizontal locus line emerging from point O. So this point of intersection, this is the first rotation. So point of intersection will be A1. So now we can see that we have got a plan projection line OA1. corresponding to the object A, which happens to be parallel to the vertical plane. So through this point A1, we have to draw a vertical projector in the upward direction and extend it up to the locus line corresponding to the point A dash. So this is the horizontal locus line which is emerging from the point A dash. So this vertical projector line, so which is emerging from the point A1, so this should intersect with the horizontal projector line which is emerging from the point A dash. So this point of intersection will be A1 dash. So once we obtain this point A1 dash, now we have to join this point A1 dash with the point O dash. And this blue line, it represents the true length of the ray of sight or a string which is going to join this particular observer location with the location of the object A which is situated onto the ground. So once we have this true length corresponding to the string or ray of sight OA, so we have been successful in obtaining the first solution, that is the distance between observer and the object A. So this true length we have been able to obtain, and once we obtain this true length, so the angle of inclination of this ray of sight or the string with respect to the ground, that is theta A angle, has also been evaluated. So the first true length we have been successful in evaluating. Now let us evaluate the true length corresponding to the object B. So now we can check our front view O dash B dash, it is inclined to HP, but our top view, it is already parallel to the vertical plane. So we have got point O which is describing the location of the observer in the top view. Here we have got the point B which is describing the location of the object in the top view. So this apparent projection length corresponding to the string which is going to join observer as well as the location of the object in the plan. So this distance in the plan OB, it is already parallel to the vertical plane. So since this apparent length in the plan, that is OB, it is already parallel to the vertical plane, so we need not make any rotation over here. So these 2 points, if we draw the vertical projector upwards, so we find that O dash and B dash, they have already been obtained. So automatically, so without making any rotation, O dash B dash, it is already giving us the true length of the line. So it means that this apparent length O dash B dash, it is also equal to true length of the string or the ray of the sight which is going to connect the observer who is situated at the top of the tower and the object B which is situated onto the ground. This is possible because the object B was located in the westward direction. So since the object B was located in the westward direction, so this direction is already parallel to the vertical plane. So no rotation of OB will be required into this particular case. So since OB, it is already parallel to the vertical plane, so the front view projections corresponding to OB, that is O dash B dash, so these projections, they determine and they provide us with the true length of the string or the ray of the sight which is going to join the observer and the object B which is lying at the bottom of the ground. So this way here the apparent length, it is equal to the true length. So we have been able to obtain true length of the string or the ray of the sight which is going to join the location of the observer with the object A, and OB, O dash B dash, that is second blue line over here. So this is the string or the length which is going to be available with us according to the length of ray of sight between the observer location at the top of the tower and the object B which is lying at the bottom. And now we can also work out the angle of inclination of this ray of sight or the string between the observer and the object B. So this angle of the true length and the ground or the horizontal plane will be angle theta B. And another thing we are required to evaluate, that is the distance of the object from the observer. So this we have evaluated through O dash A1 dash and O dash B dash. Now second thing we are required to evaluate is distance of the object from the tower. So distance of the object is over here. Please check this point. Let us say this point is point T, because T stands for the tower. So the bottom of the tower we have labeled as point T. So this point is point T. So the front view will become T dash. So the distance of object A from the tower will be A1 dash T dash. Please check. Distance of object A from the tower will be A1 dash T dash, whereas the distance of the object B from the tower will be B dash T dash. So A1 dash T dash, it is the distance of the object A from the tower, whereas B dash T dash, it is the distance of the object B from the tower. So this way we have been able to evaluate the distances of the rays of sight between the observer and the two objects, distance of the objects from the tower, and the angles of inclinations of these objects from the ground over here, right? So this way we have been able to convert this real life environment situation into the orthographic projections of the oblique line, and then we have used the fundamentals of rotation of line method to evaluate the true length of these rays of sight or the strings which are going to join the observer with the two objects which are being viewed from the top of the tower. So this is all for today. So we will be continuing with further discussion regarding few more cases of the projections of the oblique lines in the coming lectures. So thank you very much. Thanks a lot.